Hello, my name is Mohamed Saeed. Today we're going to discuss one of the most important routing protocols in the industry. The protocol is called the Ospf. So let's first of all know what Ospf stands for. It stands for Open Shortest Path First. This is a link state routing protocol that uses its code, uses the cost as its metric, right? And it uses the SPF algorithm to calculate the best path to the destination networks. The link state routing protocols send updates about the changes that happens to a specific link, unlike the distance vector routing protocol, which is the other type of the interior gateway routing protocol that sends periodic update, including the entire routing table to other routers in the same network. This actually consumes the resources, and it can actually affect the efficiency and the performance of the network. This actually doesn't happen with the link state routing protocols. We would like to know why we use the Ospf over other, or why we prefer to use Ospf over other routing protocols. The reason is that, as the name implies, it stands for Open Shortest Path First. So actually, it's an open resource that can actually be developed by different organizations. So actually, each organization can have its best use of the routing protocol. It's vendor free, so it operates on different devices, unlike the ERGRP, for example, which is a Cisco proprietary and operates only on Cisco devices. So this is one limitation which is not in the Ospf. Ospf has fast convergence over other routing protocols, and it's the most popular interior gateway routing protocol in the industry. Right now, let's have an idea or a brief description about the operation of the Ospf. To understand the operation of the Ospf, we have to be familiar or aware of some concepts which are introduced in the Ospf, such as the router areas and the neighbor relationship, or neighbor routers, and the DR and the BDR. So first of all, let's start with the DR and the BDR. The DR actually stands for the designated router, and the BDR stands for the backup designated router. What happens is that why these were introduced? They were introduced to limit or reduce the amount of the data which is, or the update which is exchanged between the routers in the same network, right, that runs Ospf. So what happens here is that we elect a designated router, right? We use the priority, right? So the router with the highest priority will become the designated router, and then all of the other routers, they are going to share the information and the update with the designated router, and the designated router is going to pass the updates to other routers in the same network. So we have like a center point of spreading the updates. The backup designated router, as the name implies, it's going to take over the DR when it fails over. The introduction of new routers in the same network after the election has already taken place. It's not going to affect the existing DR or the BDR. Second of all, let's discuss the neighbor relationship, right? In an Ospf network, routers that run Ospf is not going to exchange information until they form a neighbor relationship. They form the neighbor relationship in the same way the ERGRP does, or a similar way that the ERGRP does, using hello packets. So what happens here is that the Ospf enabled routers, they exchange the hello messages, right? They have to agree on some parameters like the hello and dead intervals, like the area ID. They have to be located in the same area. If no, then they will not form a neighborship, a neighbor relationship. Third of all, it's the authentication password. That's very obvious. They have to share the same password in order to be authenticated, to share information with each other. And finally, the net mask, right, or the subnet mask. So once they agree, there will be other phases, right? But actually, this is the most important thing to agree on. After that, when the neighbor relationship is established, they will start to exchange information normally, right, in the network. So actually, this is like brief description about the neighbor relationship. Third of all, it's the areas, right? So what happens here is that the areas, as we can actually see here, areas in the Ospf are introduced in order to reduce the amount of the updates, right, between the exchange between the routers, and at the same time to simplify the administration of the network. So what happens here is that, as we mentioned before, that the routers in the same area, right, are going to exchange information with each other because they belong to the same area, while other routers will not actually share information with the routers from a specific area because they do not belong to the same area. So what we have done here is that we have already divided the network into areas, and we have already localized the updates into one single area. This is going to reduce the consumption of the resources and is going to increase the performance and the efficiency of the network, right? Second of all, we need to know that in a good Ospf design, we have always to start by designing area 0, which is called the backbone area, and all of the other areas in the autonomous system or Ospf autonomous system has to connect directly to Ospf. Otherwise, this is going actually to violate the rules of engagement of Ospf, right? And this means that actually the network it's not going to operate properly, right? Before we actually discuss this, the concept or the idea of the full Ospf design, we would like to discuss another advantage of the area or the areas in your Ospf, which is the summarization, right? It allows summarization. So what happens? Let's just imagine something here. For example, in a good design, as we mentioned before, that we need to have a good design. We have a contiguous network. For example, let's imagine here that in area 0, which is the backbone area, we have routes from the network 10, 0, 0, 0, or 10, 1, 1, 10.1.1.0, right? And we have already, this actually is going to be our summary route, and we are going to pass this summary route or to configure this summary route on this router over here, right? We're going to explain what this router is right now. So what happens here is that in this area, for example, if we have 50 routers and one of the links actually went down, what will happen here is that all of the routers inside of this area is going to exchange information about this through the DR and the BDR, right? So actually in the same in the same area, the DR is going to handle the process of spreading the updates to other routers, while actually other areas will not be aware of this exchange of these updates because actually there is no need. Because what will happen is that if there is an update or a traffic or data that needs to be sent from this area to that specific link that went down, is going to enter that router, and then the router is going to say that actually yes, I do have a similar route to this network, and then when it goes to that area, it will go to the DR, and finally it will end up by being discarded because actually the link is down. So actually there was no need in the first place for this area to know about this. So actually we have saved the resources, and we have saved time as well. So actually this actually have increased our performance, the network performance, right? So let's actually finally discuss the role of these routers over here. We can see here that actually these routers are located on edge of networks, or I'm sorry, edge of areas between two areas. So these routers here, what they do is that they exchange information or the update between different areas. This router, for example, here and over here, since they are actually in the same autonomous system, they are called and they are located on the edge of the networks. They are called the area border routers. What they do is that they exchange information between different areas, while this one is called the autonomous system border router, which stands for the ASBR. And what it does is that it exchanges the information from autonomous system to our Ospf autonomous system. Finally, we would like to discuss the role of the virtual links. What the virtual link does is that in poor network design, if we have, for example, another area right here connected to area 2 and not connected straight away to area 0, we can actually use the virtual link in order to trick this area so it will think that it's directly connected to area 0, and this actually is going to help us to operate properly, right? But we do not actually advise that we plan to have such design for our network. This actually was a brief description about the role of the virtual links and Ospf in general. I hope that actually that was informative for you, and I would like to thank you for viewing. Thank you.